So as we move on to our last set of problems here from Chapter 3, I wanted to take a moment and review, again, 5 skills that are important for Chapter 3. We first learned about the mole, and again, the mole is important because that's how we count items in chemistry. So if you're ever confused about how to start a problem or what to do with a problem, there's a good chance that converting to moles is going to be something that's helpful. And then again, why we have this little mole game sheet is because whether we're talking about masses of substances that we convert to moles by molar mass, quantities of substances, numbers of items that we convert to moles using Avogadro's number, or this new section using volumes of a solution to convert to moles using molarity. Once we get to moles, then again using a balanced chemical equation will allow us to change who we're talking about. So mole is kind of a central concept in chemistry. Thinking about empirical and molecular formulas is important because it relates the number of moles of atoms within a substance. So again, relative number of atoms in empirical formulas, actual number of atoms in molecular formulas. Then we moved on to balancing chemical equations. Again, that's a really important skill in general chemistry because that is what allows us to change the species that we're talking about and relate moles of one substance to moles of another using a balanced chemical equation. Our last few problems dealt with stoichiometry, concepts of limiting reagents and reagent quantities, reaction yields, and so forth. So the last section here is truly not anything different or completely a new subject. When we talk about solution chemistry, really it's dealing with how the majority of chemistry really happens because liquids are easier to store, easier to mix, and we can measure amounts very precisely when we measure volumes. So again, our previous solutions to stoichiometry problems had to deal with converting amounts in grams to moles using the molar mass. Now, again, we're going to precisely determine the amounts of materials we have by measuring a defined volume, and then using the molarity, which has units of moles per liter, we can convert a volume to moles. Again, and this has come up as several people have worked through problems. There's lots of things that we'll work with that might be a value that has 2 units. For example, molar mass has units of grams per mole. So when we have units of grams and moles, grams per mole, that means that molar mass is an interconversion between those two. So grams and moles, the unit conversion to walk between those has both of those units. So again, walking between volume and moles, liters and moles, the unit to walk between is molarity, which is moles per liter. So keep that in mind as we're working through problems, that if you can't think about how to walk from this to that, ask if there's a unit conversion that relates those two. So again, our last few problems, we have 4 sample problems that we'll work through. The first is dealing with the concept of molarity, thinking about solution dilutions, and then finally working through some stoichiometry problems using solution chemistry. Okay, so our first problem is pretty straightforward here. Just thinking about this concept of molarity and figuring out what mass of a solute would be in a given volume of solution. So they tell us that we have a solution of sodium monohydrogen phosphate as a buffered solution. We don't need to worry about what a buffer is right now. But we want to know how many grams of that solute would there be if we have 1.75 liters of a solution that's 0.460 molar. And so again, key to solving this problem is recognizing that molarity is the number of moles of solute in a liter of solution. Okay, and so they actually tell us how much solution we have, and they give us the molarity. So hopefully people can see we can calculate the moles of solute that we have. And we've already talked about, with most of the problems we've done in this chapter, a walk between moles and mass is molar mass. So again, we have the roadmap here that's already provided for us by the textbook, but let's make our own roadmap, right? If we want to talk about information that we know, right, we know the volume that we have of solution. And this is, again, another kind of roadmap I like to draw that shows the units that we're given, and then we have how we're going to walk between those. If we want to go between volume in terms of liters and moles, this time of sodium monohydrogen phosphate, we can use molarity to do that. And again, walking between moles and grams, we can use the molecular weight. So notice that these are different M's. This is kind of a scripty, or a regular M, and then your book uses kind of this scripty looking M to represent molecular weight or molar mass. But before we even do that, in order to think about the correct molecular weight, we have to know exactly who we're talking about. And herein brings in chapter 2 kind of concepts. They tell us that we have sodium monohydrogen phosphate. So monohydrogen phosphate means that we have H, monohydrogen, one hydrogen, monohydrogen phosphate. Well, remember, if we had PO4, that would be 3 minus. If we add 1 hydrogen to it as H plus, that means this is 2 minus, or minus 2. So sodium is always plus 1. So we're going to need to have 2 of these in order to neutralize the charge there. So this is going to be Na2 HPO4. So that's who we're talking about, right? So we have a volume of solution. Using the molarity of that solution, we can find the moles of Na2 HPO4. And from there, we can find the grams of Na2 HPO4. All right, so now we're ready to execute and solve this problem. So we're going to use our roadmap here, and we're going to put in the information that we're given. So we know that we have 1.75 liters of that solution. We're going to multiply that by, or we're going to use the molarity. Now keep in mind, molarity comes in moles of solute per liter of solution, or we could use it the flip way. It depends on what we're walking between. Now, we know we want liters of solution down below because we want those units to cancel. So that means we're going to use it as written up here. Per 1 liter of solution, we have 0.460 moles of that sodium monohydrogen phosphate buffer, so Na2HPO4. And it was important that our chapter 2 skills are honed well so that we knew exactly how to figure out the molecular weight of this, because 1 mole of Na2HPO4 is 141.96 grams. Now moles of Na2HPO4 are going to cancel, and we end up again to 3 significant digits. Both of these values have 3 significant figures. We end up with 114 grams of Na2HPO4. So again, with this problem, there's truly not that much that's new compared to everything else that we've studied in this chapter. The only thing that's truly new is now we have a walk between the amount of material as measured in a volume of solution and moles. And again, that walk between is molarity with units of moles per liter.